Going to start with asynchrony. I would think asynchronicity, but that's my Dutch foreignership. In SaxonJS, I hope most of you know what SaxonJS is, and hopefully Debbie will explain, but probably she'll just talk about promises.
Promises, yes. So hopefully you can all hear me, and I've got the mic right. Hello, everybody. I won't just say good morning, because hopefully we've got some other people around the world viewing in, and it won't be morning for you, but thank you for joining us. So it's really good to be back here in Amsterdam after quite a while, and it's very nice to have this opportunity to talk to you about SaxonJS again. So for the next major release of SaxonJS, we've been working on various developments and new features. And in this presentation, I'm going to focus on just one area of work, which is asynchronous processes, or handling asynchronous processing. Internally, we've made various changes. So we've updated the implementation to now use promise-based APIs. And in parallel to that, we're introducing new promise-based XSLT extensions for the users of SaxonJS to then do asynchronous processing as well. So promises will hopefully be familiar to people in the JavaScript world, and so hopefully for them, what we're now introducing will be familiar and you'll be able to get started. But I imagine there are a number of people that do not already know about promises. So I'm going to be giving something of an introduction here. Hopefully that'll give you enough information to be able to use it if you want, or at least know what the topic's about, or something like that. The outline of the talk, aiming to introduce these new extensions in XSLT that we use in SaxonJS. And so I'll give something of an introduction and discuss the motivation of why we've got there. Then background on asynchronous processing and how it works in JavaScript, and the difference between different ways of doing asynchronous processing, of which promises are the modern way. And then we'll look at the new IXSL syntax and look at various examples of how that can be used. Okay, so start off with the introduction. So hopefully most of you will have heard of SaxonJS at least already. You might well have seen me talk about it at a different conference, or even at this conference before. But then there might be some people that don't already know anything. So here's the brief intro. So SaxonJS is an XSLT 3.0 runtime processor that runs in JavaScript, so in the browser or on Node.js. And it runs XSLT by executing a compiled form of your XSLT style sheet called an SEF, which can be either generated by the Saxon EE product or by SaxonJS running on Node. And so you export to that compiled form. And if SaxonJS is completely new to you, and if this talk interests you a bit, or you want to find out more, then of course you can go to the Saxonica website and find various information. And if you want to learn how to get started, then there's a tutorial that Norm and I presented just a couple of years ago at Declarative Amsterdam. And so the GitHub project is available, and the tutorial notes and the video from this talk. So if you want to go back to that, then please do. Okay, so asynchronous IXSL, and I've not really said, so IXSL is interactive XSLT. It's just the form of extensions that we use in SaxonJS, or the namespace that we use for those. So the way that we currently provide that mechanism in SaxonJS as it is at the moment is via an instruction called IXSL schedule action. And let's dive straight into an example and see what that looks like. So here we've got an event handling template, which is going to catch click events on a button in your page. It's then going to call the schedule action instruction, which will go and fetch a document. So the document attribute tells you which URI to go and get from. And then the contained call template inside that defines the deferred action when your document has been fetched asynchronously, then you will go and do what the call template is. So here we call the action template, and in that one, once your document has been fetched, if it has been fetched successfully, we will put it in a document pool cache. And then when you get to the called template, when you call the doc function, it will then be picked up from the document cache, and you can use that document, if that makes sense. So yes, the schedule action does an asynchronous fetch on the document, and then puts in the document pool. Then you can call the document function to go and get it once you're in this asynchronous process. And this process is doing an insert into the document page. So the result document with the location with a hash in front of it is saying, go and find this place in the HTML page and insert the content there. And hopefully this is what I have just managed to say. May not have said them all. But yes, that's mainly for people that want to refer back to the slides. Okay, so it is already possible to do asynchronous processes using SaxonJS, using this instruction, but it has some restrictions and limitations. So the example I've just shown you used the document attribute for document fetching asynchronously. And then there's two other possible attributes that you can use for slightly different asynchronous processes. So there's the wait attribute, which will just create a delay of a subsequent action. And the HTTP request attribute, which can be used for other general HTTP requests. Yeah, where you just apply your request as a map, and it will return the response comes back as a map. Why would I? Okay, we do come to that. Yeah, but yeah, I guess it's a good question. You can think about it some more. But yes,
Debbie,
hello.
He didn't use a mic, so maybe you should have repeated the question, even though it was irrelevant.
It wasn't an irrelevant question. So yeah, the question is, why do you not just want to do this synchronously? Why do we want to do this asynchronously? And maybe some of you already know the answer to that, but we will get there. So basically, it's your browser might have to wait. Like, it's a slow process. But yeah, I will come to that, sorry. But yeah, so as I was saying, the schedule action only provides this limited, restricted set of actions that you could do. And I guess this was discussed yesterday at some point of, do the designers think of everything that a user will actually want to do? Have they made, produced some syntax that is extensible and or not? And this is not so easily extensible. We have to change the syntax and add a new attribute and have a new release if you wanted to do something different to what we've already provided. So what we're doing with the new instruction, which is designed to replace schedule action in the next major release of SaxonJS. So it's a new instruction that you can use basically in the same place, but you'll be able to call any asynchronous function. So to fetch different kinds of resources or whatever other asynchronous things you'd like to do. And as I said in the introduction, it's closely aligned with JavaScript promises. And so hopefully be familiar to people that know about that. And yeah, as I also said right at the beginning, we've updated the internal implementation to use promises, because currently SaxonJS, an earlier iteration, the XML HTTP request mechanism, which was a callback mechanism, and that has some limitations. And in Node.js, currently we don't even provide HTTP access. Yeah, so you can just do file access for documents, that kind of thing. Yeah, so we're introducing new ones. Last bit of the introduction. So the syntax that I'm going to be presenting here is based on or has grown out of earlier syntax that Mike presented in Balasar's 2020 in a paper called Asynchronous XSLT. So he was looking fairly generally at a number of questions of what new syntax would be useful in the XSLT world. We're now being quite specific about, well, we just want it for SaxonJS, and what do we want to do for ours? And that paper contains some further, more ambitious proposals about other limitations, which I'm not going to go into detail here. And yeah, we haven't decided yet how much of those we want to attempt to get in the next release, or what can be a bit later. But yeah, I want to present where we've got to now. Okay, so let's go back to Ken's question, kind of. So why do you do asynchronous processing in the first place? So something like making an HTTP request to the server to load a document can be a slow operation. So from the browser, or from your client side, if you want to fetch a document, you might have to wait for that connection and wait for your response to come back. And in JavaScript, that will be a blocking operation. Nothing else will be able to happen at the same time. So if it's synchronous, so your browser will become inactive. You won't be able to do something else, click on anything else, or you start clicking on something else and it'll then get in a mess. So instead of doing it synchronously, you should do it asynchronously. And then that allows different processes to happen at the same time. And as I kind of mentioned, HTML on Node.js, you can only do HTTP requests asynchronously, not synchronously in the first place, because of those limitations. So how do you write asynchronous code? One approach, the first approach, is to use callbacks. So this is where the function that you've got that wants to perform an asynchronous option, like fetching a document, you will supply an extra argument, which will supply the callback function. So the operation is started by calling the function asynchronous operation in the first place, and then when it finishes, the callback function is going to be called on the result. Here's a small example. So this is using the Node.js read file method to go and read a file. So you've got read file, supply your file name and a callback function, which is defined up here, which is expected to take two arguments. The first one being if the read file fails and produces an error, then that's your first argument. And if it comes back and gives you the result, then that's the second argument, the data. And this one's not doing very much with it. It's throwing an error or logging your data to the console, but that shows the basic idea. So callbacks work. This is a usable method of doing things, but you can end up with various coding problems. So if you have lots of callbacks inside other callbacks, you end up with some messy looking nesting happening. and yes, something called the callback pyramid of doom, because the nesting keeps going deeper and deeper. Yeah, it can be difficult to keep track of where you are there, and the error handling can be messy if you want to handle errors at certain levels or where they are. So the JavaScript solution, I guess other languages as well use promises, promises are the way to do it in modern JavaScript. So rather than arranging for a function to be called at some point in the future, the idea instead is that you return an object that represents the future event of the action being completed. And so a promise is an object representing the eventual completion or failure of an asynchronous operation. And rather than passing callbacks into a function, we attach handler functions to the promise object. Right, you can read that. I'm going to have a quick trick. I won't put it up here because I think that's asking for trouble. So some promise terminology, which I'll hopefully stick to in this talk. So a promise can be in one of three states. It starts off being pending. So when you first create your promise, it's not done anything yet. So it's pending. Then we say it's fulfilled if the asynchronous action completes successfully, and rejected if the operation fails. And then you also say that a promise is settled if it's either fulfilled or rejected. So when it's no longer pending. So the handlers are attached using the then and catch methods of a promise. So the then handler is called when the promise is fulfilled, and it acts on what you call the fulfillment value, so the result of your asynchronous process. And the catch handler is called when the promise is rejected, and that acts on the error object. Okay, so the key feature of promises. So if the rest of this is waffle and you don't remember it, I think this is the one thing that it is worth remembering. And even for me, it is worth remembering, is that the then and catch methods themselves return a promise. So when you attach one of these handlers to a promise, and the first promise, the result comes through, and then it is settled with the result of the next one, that is a promise as well. I don't think I explained that well. So yeah, the new promise is settled with the result of the handler function itself. So this enables what's called promise chaining, which makes your code look a lot cleaner, and hopefully means that you can avoid the problems of nested callbacks. So yes, if you've never seen it before, then it might make your code look a bit odd, but believe me, it does help make it easier. So here's an example, much like the previous one, where we're reading a file, but instead we use the promise-based API here. So the read file method here returns a promise. We attach a handler to it using the then, where when the result comes back, that data, this then describes what process to do with the result, which is just logging it to the console again. And the then itself also returns a promise, and we can attach a handler to that promise, which is then the catch for catching an error. And also note that if the first promise failed with an error, that catch is also going to catch that error. So this chaining, your error will get passed down the chain. Okay, hopefully that makes some sense. And then this approximate picture of what a chain could then look like. You can put a catch in your chain wherever you like, but especially it's going to be useful to have one at the end. So all of these could be a number of different asynchronous processes or synchronous processes passed down a chain, and at the end you'll want to make sure that you've caught any errors in the preceding stuff, but you might also want some in between somewhere. So here you'll note we haven't got indentation and nesting. It's just a chain of these processes. Okay, so with possibly that whirlwind introduction, we'll now go and look at the promises in interactive XSLT. So this is our new extensions for SaxonJS 3. So as I've said, we're introducing a new promise instruction, and this time it has one required attribute and two optional ones. The first attribute, select, is going to specify the asynchronous process, and it can be any asynchronous process as long as it returns a promise. And we'll come back to that. And then the two optional attributes are going to define the handler actions for if that promise is fulfilled or rejected. So we've got an attribute called on completion for the handler when the promise is fulfilled, and on failure for when the promise is rejected. I also want to say that the instruction this time has no body content, and it always immediately returns with an empty sequence. So this is going to kick off an asynchronous process, but yeah, have it all self-contained. Okay, I'm going to dive straight into what that looks like in an example. And I imagine there's going to be a lot of things on this that you don't necessarily recognize because they're new. But just to see, so this is the same example that we saw before with the schedule action, how you'd write it in the new syntax. So again, we've got the event handling template for a click on the button. We now call IXSL promise. Our asynchronous action is to fetch a document. So we've got this new function to do that. This is going to return a promise. Didn't mean to do that. The instruction defines what the action is going to be on completion. It's going to call a go function. Here's the go function. This time, the promise is going to, the fulfillment value of the promise is our document, and that's what then gets passed into the handler function. So it's this document node, and then that document node, you do what we did before, which was just insert it into the HTML page. There are some other things up there that you probably noticed that I haven't explained yet, but we will come to those. Okay, so as you saw, the mechanism takes advantage of HTML higher order functions. And yeah, the on completion and on failure attributes are used to specify the handler functions for rejected or fulfilled, the other way around. The example used this notation to direct you to the handler function, which may or may not be familiar. So that's called a named function reference. It's a named function, and you say specify how many arguments you're going to call it with. Our handler functions always expect a single argument function because you're either going to pass your fulfillment value or an error object represented as a map. So what you supply for your attributes needs to point to a single argument function. So you can either have a named function reference or a partial function application that might look a bit like that, or anything else that returns a suitable function like that. You might have also noticed in the example this attribute IXSL updating that was on the handler function. So a common requirement for your handler action is to have some sort of side effect. For instance, calling result document. But the specification says you're not allowed to have call result documents inside functions. You'll get a warning, you'll get an error. But, you know, we can fix this ourselves because Michael K said we could. We can break that rule by sticking on this new attribute, and for these specific functions will allow you to have result documents because we know that that's the sort of thing you'll want to do. So we can break our own rules. So yeah, if the promise is fulfilled, then the onCompletion function is going to be called with the fulfillment value. If it's rejected, then the onFailure function is going to be called with a map containing the details of the error, the rejection. Okay, if you can remember when I introduced promises, or you already know that we use then and catch, why am I not just using the same names here? Why are we calling it onCompletion and onFailure? And the point is, these aren't actually equivalent. So as I try to make clear, then and catch always return promises. Our functions are not returning promises. So they're kind of like the final action that you will do, but we're not expecting you to chain beyond that. Instead, there's a function that you can do for chaining. And at the moment, I've only got IXSL then. I probably should put IXSL catch in, and there's another one, finally. They would probably be useful as well. But yes, so that's the reason for those names being a bit different. In the example, I showed one way of creating a promise using the IXSL doc function. But how else do you create a promise? And we're providing a number of new core functions in the IXSL namespace for some common things that we expect you want to be able to do. So IXSL doc is like FN doc, but an asynchronous version that will return a promise. And there are other similar ones, which I'll show in just a moment. And as well as the functions that we're providing, you can also call whatever function you want to write, as long as it can returns a promise, which is a JavaScript promise that is wrapped to be passed into the XSLT space. But that's something that SaxonJS will do. So if you've written a function that will return a JavaScript function, return a JavaScript promise, it'll work. In the following, so I'm going to describe or show you more of these new IXSL functions, and I'm going to use this notation for the promise type. And this was proposed in Mike's paper from a couple of years ago, but we haven't actually implemented it as a new type. It's just used for documentation purposes. But this is one of the things that it might be a good idea to do. We probably should implement it so that there's some restrictions for you, and it's clearer for us internally in SaxonJS to know what your passing is. But yes, so a promise type, promise T, means a promise that when it's fulfilled, it's going to return an XTM value of type T. So let's go to the new functions. These ones all create promises, return promises. So these are asynchronous versions of the FN XPath functions for fetching resources. So IXSL doc is like FN doc and is going to fetch a document, but it instead returns a promise that will return a document. And then you've got JSON doc and unparsed text functions. So so doc fetches and parses an XML document. JSON doc fetches and parses a JSON document. Unparsed text fetches a resource and returns it as a string. But these are all promise-based versions. Two other functions which are much like what we currently provide for schedule action. So there's an IXSL sleep to be able to set a delay. So that's just it's just going to cause a delay on your subsequent processing. So it returns nothing. It returns an empty sequence. Whereas HTTP request takes a request represented as a map and issues that request, and then it returns a promise of your HTTP response, also represented as a map. Okay, so here we go. Here's the method for chaining promises within XPath. So there's a new method, IXSL then, which takes a promise as its first argument and a function, which is going to be the handler function for the fulfillment of that promise. And IXSL then does return a new promise, which will result from the result of the function called on the fulfillment value. So yeah, the handler function might explicitly return a promise, or it might not, but this function always returns a promise, which I think we'll see in one of the examples. In JavaScript, there's also a number of useful methods for doing concurrent processing, and we've got versions of those in the IXSL namespace so that you can use those as well. So the first two here, all and all settled, so all of them take an array of promises, and the first two are looking to wait until they've all settled. The first one, the first one will be fulfilled if all the input promises fulfill, and reject if any of them do reject. So you'll either get returned an array of all the fulfillment values, or you'll get a rejection. All settled waits until all of them are settled, so either fulfilled or rejected, and it will return you exactly all of that information. So an array of maps, in fact, to be able to tell you whether the promise was fulfilled or rejected, and then the associated value. And then the last two, you're just kind of waiting for the first one. So you either any will return. Yeah, what does that say? It will be fulfilled when the first input promise fulfills, and reject if any of them reject. Whereas race just gives you the first one to come back. So if the first one is rejected, then you'll get a rejection. Or if it's fulfilled, then you'll get that fulfillment value. yeah, so these are all going to be useful to us too, hopefully. There are some other associated functions also added to the IXSL namespace. So this one is, it doesn't return a promise, it creates an abort controller object. So this is something that's used in the JavaScript fetch API and things. You provide an abort controller to handle being able to abort some asynchronous action. And we're then providing you a way to do that as well. And you can use these with the resource fetching and HTTP request functions, and the signatures I've just shown you didn't include these on there because I wanted to highlight how close they are to the FN functions. But basically we've stuck on an extra argument where you can supply an abort controller. And you can, enable timeouts or user trigger aborts using this. Right, let's move on to examples now. So our first example, we're going to fetch a JSON document, extract a URI from it, then fetch another XML document and insert that into that HTML page. So how will we do that using our new syntax? First, we're going to use the IXSL JSON doc function to go and fetch the JSON document. We'll somehow extract a URI. Then we'll use the IXSL doc function to asynchronously fetch the XML document, and then we'll insert into the HTML page. So there are different ways that we could do this. The first way that you might do it, which is comparable to how you would currently do it with schedule action, is with nested calls. So in our first event handling template, we fire off our first promise and say, go and fetch the JSON document. And when you've got it, go to the get data function, which is here. That get data function then extracts a URI from your JSON somewhere, and then calls another IXSL promise to then go and fetch the XML document. So this is where the nesting is. And then once you've got that, go to the go function, and that's where we insert into the page. Okay, so that works, and that's how you'd currently do it with schedule action as well, instead of IXSL promise. But I didn't show that example because there's a little bit more extra code around there, and I couldn't be bothered to go into it. So this is slightly cleaner. So I guess that's a benefit of IXSL promise. The code is actually now cleaner already for this example. But yeah, so we've got nesting here, two IXSL promise calls, and I've shown you how we can use chaining instead of nesting. So let's do that. So in this version of the same example, we're going to use IXSL then to take the result of the first promise or attach a new handler to our first promise to then say what to do after that. And here we've got a new function, get data, which, so the result of the first one is going to be some JSON, and then we'll call this function, which will extract the URI, and then directly call IXSL doc function. So here, this get data function is explicitly going to return a promise as well, because it's returning the result of IXSL doc, which is a promise. And then the promise up there said that once you've done those steps, go to the go function. And so that's what you'll do. And maybe I should highlight as well. So this is going to be a common way of using the IXSL then function, use the arrow operator so that you've got the chaining like we saw before in JavaScript. So that means you pass in the result of the preceding thing as the first argument here. So we're calling IXSL then on the result on that promise, and its second argument is that function. Okay, so that looks okay, but we could do better. Extend your chain, or we'll put some more steps in your chain. So in this one, you do the same first process of using JSON doc to get your JSON document. Then the next process is going to do, okay, I just want to get the URI out of that. And then once I've got the URI, I'm then going to call the doc function on that. So I've split out my get the URI function. And then that could look like this. It takes, some JSON and extracts the URI from that. This one, you'll notice, isn't returning a promise. That's just a standard synchronous function, the usual sort of function. It's returning a string. But when we call IXSL then with that function, that will definitely return a promise whose fulfillment value will be the result of that process, that function. And then we pass that to the doc function. So this is a bit of a simplification of that same example. And if you really like compressing your code and including it all in one place, then you could inline that function rather than have it as a separate XSL function. So here it's the exact same function, but I've inlined it to say from your JSON, extract the URI as a string. Okay. And I'm running out of time, but that's good news. Okay, there's next example. So yeah, I've just got a couple more examples to show. So this next example is showing how to you can now fetch multiple resources at once and proceed when they're all available. So we're going to fetch an XML document and a text resource, and we're going to use IXSL for all now to fetch them concurrently. So this is what that might look like. So we've got an IXSL promise, and the promise that we're going to fulfill is we'll use an IXSL call, supply an argument of promises to fetch an XML document and a text resource. And I guess in this one, I've also included the on failure. So if there's an error, if there's a rejection in your promise somewhere, then how that might get processed. The error object is represented as a map, and there are various details about the error that you can then access, the message, the code, the name, probably, that kind of thing. And it shows something you could do with that. And if it's successful, so this is a bit of a just an illustrative example. So we're just outputting, we're combining both of our resources into one document here. And then one more example, just to see what abort controller looks like. So we're going to fetch a document, but have a timeout on that fetch. And that could look like this. So you'd have an IXSL doc call and supply as your additional argument an abort controller, which will abort the fetch after 1 second, so 1,000 milliseconds. And then what you might want to do with that. And that's kind of the end of what I'm trying to show. So the summary is that I think we've made good progress with the new design for promise-based IXSLT. And hopefully I've given you a good idea of what's to come, or a flavor of what's coming. You can do everything with this new instruction that you could previously do with schedule action and more. And if JavaScript promises are familiar to you, then this should be a bit easier, hopefully, once you get used to it, I guess. And then, as I mentioned before, there's further, what further things could we do? There's a number of suggestions, or there's a couple of suggestions in this paper of Mike's from a couple of years ago that we might still want, and users might start demanding, why can't we do these things as well? So that's something for us to consider for the future. And that's the end. Thanks for listening.
Thanks very much, Debbie. We're in a bit of a hurry now. I have a question. When can we have this?
Yeah, so when is SaxonJS 3? Next year?
Sometime next year. Okay.
Yeah. As soon as possible, but I don't know. Is it an asynchronous process? So we don't know how long it'll take. It takes some time.
And there's another question from myself.
Yep.
Will schedule actions still be supported, or will it be fully replaced?
It will still be supported,
Okay.
because, I think that's too much of a step to suddenly say, no, you can't have anything that you had before. We need you to learn it straight away. Okay. So no, it will still be supported, but then it's going to be deprecated, so it will go in a future version.
John Lumley.
John.
Hi, Debbie. You're not using the promise type implies that basically you're going to be doing dynamic runtime type checking against promises, and there's no static analysis. Is that the case?
Yeah, you're assuming that I'm even doing some checking at the moment. But yes, probably, John, yes.
Okay, all right.
Thanks.
Anybody else?
I guess this is why we should implement something, yes.
Hi, Debbie, thanks.
Hi.
That's really cool. I was just thinking, and this is sort of a thought exercise. The functions IXSL doc and IXSL JSON doc, if I understood, they're sort of equivalents to FN functions, but they yield promises.
Mm-hmm.
Why do you need to do that? Why would it be possible, or maybe it's not possible, to have something that just wraps existing like FN namespace functions so that the user could, I don't know, use anything they want without having to have all these IXSL mirrored kind of equivalents? I don't know if it's possible.
Yeah, what would that wrapper look like? Is it just a thing and then you can do whatever you like? I guess are we still limited on which things we allow you? So I guess we're providing them already as a convenience, and the fact that they're in XPath and you'd want to be able to do them, then because we don't want you to do them synchronously, we want to provide a way of doing them asynchronously. But yeah, could we just let you do anything? Oh, hang on, microphone.
Thank you.
There are issues, and I don't know whether we'd be able to overcome them, because I'm very much like a bystander on this stuff. But if you think about it, what you're actually making asynchronous are the network calls, and that's not like an input to the doc function or the JSON doc function. Those things happen inside. So there's a kind of like, if you don't provide a wrapper like we're doing here, how do you shim the stuff to make the asynchronous stuff? It's interesting. It's also like a bit of a mind bender and kind of hard. But it is interesting.
Yeah, but whether there's another way of having a different sort of wrapper, I don't know. But yeah, we want to know. Yeah.
Thank you very much, Debbie.